Hello students, this is my third lecture for the NET aspirant students. In the last class we discussed about 5 specific problems, and today also I am going to discuss 5 specific problems of physics. The first problem that I am trying to solve is the wave number k and the angular frequency omega of a wave are stated by the dispersion relation omega square equals to alpha k plus beta k cube, where alpha and beta are positive constants. The wave number for which the phase velocity equal to the group velocity is, there are 4 options. This is a very simple problem. You are given the dispersion relation omega square equals to alpha k plus beta k cube. Okay, and you know that phase velocity v suffix p equals to omega by k, and the group velocity vg equals to d omega by dk, right? Now if you come back to the relation and take the derivative on both sides with respect to k, then you will have twice omega d omega by dk equals to alpha plus 3 beta k square. You have taken the derivative on both sides with respect to k, and therefore d omega by dk, which is nothing but the group velocity, equals to alpha plus 3 beta k square by twice omega. Now we want this should be equals to the phase velocity, that is omega by k. Now we pick up this relation. From this we can write twice omega square equals to alpha k plus 3 beta k cube, right? Just doing the cross multiplication, and you know the relation of omega square, and therefore you can write twice alpha k plus twice beta k cube, this is twice omega square, equals to alpha k plus 3 beta k cube, and therefore you can write alpha k minus beta k cube equals to 0. That means if you take k common, alpha minus beta k square equals to 0. The consequence is either k equals to 0, which is unphysical, or k equals to plus minus square root of alpha by beta. So this is the value of k for which leads to the phase velocity equal to the group velocity, and therefore if you go to the options in the problem, then the third option is the right option. Okay, now let's move to the second problem. Second problem that we are going to discuss is a particle in a box problem. It's a very common problem in quantum mechanics. Okay, so this is a particle in a box problem. Now look at the problem. The wave function of a free particle of mass m constrained to move in the interval minus L to L is this, the wave function. Find the probability that the particle will be found with energy this, a pi square h cut square by twice m L square. Okay, this is a very familiar system. Now let us draw the potential, square well potential. Okay, So this is, if this is center is 0, this is minus L, this is L, therefore the width of the well, infinite square well, is this. And we know if we solve this problem, then it will have the stationary states denoted by phi n, say x equals to square root of 2 by twice L width, and then sine of n pi by twice L into x plus L. If it was from 0 to twice L, then it would have been n pi x by twice L. But since it is extended from minus L to plus L, and therefore you have to see that boundary conditions are satisfied, and accordingly you have to write the wave function. You see, in this case, when x equals to minus L, this is 0, and therefore the wave function at this should be 0. And when x equals to L, it is twice L cancels, so n pi sine n pi is 0, and therefore it is 0 here. And therefore this wave function is fine. And n runs from n equals to 1, 2, 3, that you know. And corresponding energies are En equals to n square pi square h car square by twice m into width square equals to n square pi square h car square by 8 m L square. So these are the informations are known to us for this system. Now you are given that psi, initially the particle is prepared in this box in such a way that the wave function takes the form this. So psi, this is the initial wave function, okay, that is given as a times L minus x plus x into L minus x. That means it is equals to a into L square minus x square, and this is a symmetric function, okay, because when L equals to minus L, x equals to minus L, then this is 0. When x equals to L, this is equals to 0, and when it is x equals to 0, then it is a maximum. Therefore this is a symmetric function, okay. Now we have to find they're asking to find the probability that the particle will be found with energy pi square h car square by twice m L square. And we see this is the energy for the states n equals to 1, 2, 3, 4. Then for what is the n value for which En equals to pi square h car square by twice m L square? You see that if n equals to 2, then n square is 4 pi square h car square by 8 m L square is n square. That means e equals to 2, it is pi square h car square by twice m L square. That means the corresponding the state wave function phi 2 equals to root over 1 by L sine of n is 2, right, 2 pi by twice L into x plus L. That means phi 2 x equals to square root of 1 by L sine of pi plus pi x by L, right, and this is nothing but minus square root of 1 by L sine of pi x by L. So this is the wave function corresponding to the stationary state whose energy is pi square h car square by twice m L square, and therefore we would like to find what is the probability that the energy measurement will give you the value this. It means that how much portion of this wave is contained in this general wave function, and therefore we take the projection psi in x and phi 2 x and then take the mod square. So this will give the weight factor and take the mod square, and it will give you the probability. Okay, so this is nothing but equals to mod square inside minus L to plus L, the integration, because it is ranging in the space from minus L to plus L. Then this one psi in A times L square minus x square, and then psi 2 is minus square root of 1 by L sine of pi x by L, and then dx, and then mod square. Now if you look at it carefully, you see this is the even function, but this is odd function, and this odd function from minus L to plus L, if you integrate over, and that will give you 0. So simply the probability that the particle will be found with the energy this is 0. Okay, so this is what is the answer, and this is a very common problem, and similar kind of problems appear in NET examinations. Now we look at the third problem. The third problem says that it's a problem from probability. Okay, so a box contains 100 coins, out of which 99 are fair and one is double-headed coin. Suppose you choose a coin at random and toss it 3 times. It turns out that 3 tosses are head. Then what is the probability that the coin drawn is double-headed? Again, look at it. You have total 100 coins, out of which there are 99 fair coins and 1 double-headed coin. Now you choose a coin at random from this and you toss thrice, and the result you get is that 3 times you get head. Okay, so you toss 3 times, it turns out that 3 tosses are head. Then what is the probability that the coin drawn is double-headed? Now you see, before discussing this problem, let me discuss a bit about Bayes' rule. Okay, it tells you that suppose the events, say A1, A2, A3 and so on, there are many events, say n events, and the probability occurring of an event B, okay, it depends on all these events. So when A1 occurs, this event occurs, then there is a probability that B will appear. If A2 occurs, then there is a corresponding probability that B will appear, and therefore for all events there is a probability that B will occur. Then here the question is asked, what is the probability that B has occurred? Then what is the probability that it occurred due to the event, say A2? This I am asked. So B has occurred, then what is the probability that A2, the earlier event A2, occurred? Okay, then it should be the total probability of B occurrence and the probability of occurrence of A2, and then probability of occurring B if A2 has occurred. Okay, and what is this PB? PB is equals to the total probability. That means the sum over probability that any event occurred and then probability that B occurs while any probability AI occurred and sum over. This is the total probability of B. And therefore in this problem, now let me discuss this problem. Okay, in this problem you have 100 coins. Okay, now 99 fair coins and 1 say double-headed coins, say fair coin and double-headed coin. Now, if you draw a coin, there is a probability that you will get a double-headed or a fair coin. If you take a fair coin, then also you have the probability that it will occur head 3 times if you toss 3 times. And again, if you draw a double-headed coin, then there is also a probability that you will have head 3 times. Okay. Then I am asking, what is the probability that when 3 head occurred, what is the probability that I have drawn double-headed coin? Then it should be the total probability of occurring 3 head from whatever event, whatever coin is chosen, and then the probability that you have chosen the double-headed coin, and then multiplied by the probability that 3 head occurs while a double-headed coin is chosen. Okay, that means it should be equals to P double-headed coin probability that you have chosen this, and then probability that 3 head occurs provided that double-headed coin is chosen. And then here it will appear from both the coins. So first, the probability that double-headed coin is taken, then probability 3 head due to double-headed coin, plus it should be the probability that you have chosen a fair coin, and then probability that 3 head provided that you have chosen a fair coin. So this is the total probability, that is the probability that while you have 3 head appears, then what is the probability that you had drawn the double-headed coin. Then it should be equals to, what is the probability that you have chosen double-headed coin? It should be 1 by 100, because out of 100 only double-headed coin, one double-headed coin. And then once you choose the double-headed coin, then what is the probability that in 3 tosses you will have 3 heads? Of course, one every time will give you 1. Then similarly in this case, this is also 1 by 100 into 1, plus what is the probability that you choose a fair coin? There are 99 coins out of 100, then it should be 99 by 100, that is the probability of choosing it. And then what is the probability that a fair coin will give you head thrice? Then it should be 1 by 2 per cube, right? And therefore it will give you, if you take common 1 by 100, this is 1, this 1 by 100 goes 1 plus 99 by 8, right, equals to 8 by 107. So this is the probability that 3 heads appeared in 3 consecutive tosses. Then the probability that you had chosen or you had drawn a double-headed coin. Okay, this is also a very common problem that appears in this kind of problems appear in NET examinations. Okay, now let me move to the next problem. Next problem is that which of the following set of matrices form a group under matrix multiplication, given that alpha and beta are complex numbers. So there are 4 options. Then if you want to pick up the right answer for this, then you have to check the group properties, right? So very important properties of group are the closure relation. Now if you look at this, these are the matrices of 2 by 2. Now you have to see whether closure relation exists, whether the inverse exists, whether identity exists, and so on, right? Now if you look at this matrix, then of course if you multiply 2 by 2 matrix with 2 by 2 matrix, then it will give you a 2 by 2 matrix, right? And again, this alpha, beta minus beta star alpha star. The determinant is alpha mod square plus beta mod square. This is 1, this is non-zero, and therefore inverse will exist. Now if you multiply two matrices, say alpha beta minus beta star and alpha star, okay, then if you multiply with another, say alpha prime beta prime and then minus beta prime star and alpha prime star, this equals to, it will give you alpha prime minus beta prime star, and the next one is alpha beta prime plus beta alpha star, and if you multiply here, this is minus alpha prime beta star minus beta star alpha star, and this one is minus beta star beta prime and plus alpha star alpha prime star, like this. Now see, this is alpha, this is alpha star. If this is this, then what is the conjugate of this? It should be minus beta star beta prime plus alpha star prime, okay. And if this is beta, this is minus beta star. If this is beta, then what is the star? Alpha star beta prime star, this one and this one, this is beta prime star, right? Beta prime star, this one, this alpha beta prime star, yeah. So this alpha star beta prime star with a negative sign, and this is also beta star and alpha, this is alpha prime again, this and this is alpha prime, right? Okay, so this is obeyed. So this structure is obeyed in this case if you do the multiplication of two matrices of this kind, okay. And determinant is also 1, which is non-zero, and identity, of course, if you take 1 alpha 1 beta 0, then it becomes identity, and therefore it does obey all the properties of group, okay. Now if you look at the others, then you see that for this one, say this determinant is 0, so inverse doesn't exist. For example, this, now if you multiply with another matrix, then this structure is not preserved, okay, and therefore this will not hold good. And again, if you take the determinant of this, if this is real, then again this determinant is 0, therefore inverse doesn't exist, and therefore the right option in this case would be this, because all the group properties that are satisfied for this set of matrices, and therefore this set forms a group, okay. And the last question today I am going to discuss is from classical mechanics. The question is this: the Hamiltonian of a relativistic particle, the Hamiltonian of the relativistic particle of rest mass m and momentum p is given by h equals to square root of p square plus m square plus vx potential, and c is 1, okay. Then the corresponding Lagrangian is, there are 4 options, you have to choose the right. This is the relativistic particle, okay. And therefore you see from Lagrangian and Hamiltonian mechanics, you know that h, the Hamiltonian, equals to p x dot, if this is the generalized coordinate and this is the generalized momentum, minus L, and therefore from this you can write L equals to p x dot minus h, and that is equals to p x dot minus, and h is given, right, square root of p square plus m square minus v of x. So this is your L. Okay, now you know that L is a function of x, x dot and t. Okay, now you have to find this or convert it in terms of x, x dot and t. Okay, now let us try. You know from the equations that x dot equals to Hamilton's equation del H by del P. Your H is given, H equals to square root of p square plus m square plus v of x, right? This is given, and therefore this should be equals to half p square plus m square whole to the power minus half into twice p, and therefore it is equals to p by square root of p square plus m square, right? And or you can write p equals to x dot square root of p square plus m square. And again it's a relativistic particle, and therefore we can write p equals to m prime x dot. Okay, and this mass is m is the rest mass times x dot by square root of 1 minus x dot square, because c square is 1, right? So this is what is the value of p. Now if we substitute all these things in this, then we can write L equals to p x dot. What is the value of p is this, so m x dot by square root of 1 minus x dot square into x dot p x dot minus square root of p square plus m square. From this relation, square root of p square plus m square equals to p by x dot, and that is equals to p by x dot minus v of x, and that's equals to m x dot square by square root of 1 minus x dot square minus p. What is p? Is this, and therefore x dot and x dot cancels. It becomes m by square root of 1 minus x dot square minus v of x equals to, if you take all this common, then it will be minus m square root of 1 minus x dot square minus v of x. Okay, so this is the expression for the Lagrangian corresponding to the Hamiltonian given here. Okay, corresponding to this Hamiltonian, the Lagrangian is this, and therefore in these options this is the right answer. Okay, today let me stop, and again I'll come back with a new set of problems. Okay, till then, thank you so much.